Hello, SQL Server 2016 RTM has just been released. It's a huge milestone for Analysis Services Tabular with the new compatibility level. It provides a much more responsive developer experience, fast communication between the IDE and the workspace database because of lightweight JSON-based definitions, and it just feels like a more finished product now. For example, we have bidirectional cross-filtering for many-to-many dimensions, calculated tables for role-playing dimensions, and I feel just the little details like display folders are what's going to allow many more people to migrate from multidimensional to tabular. I encourage you to consider BISM Normalizer 3 for deployment of tabular models with the new compatibility level. If we walk through the traditional use cases for the Analysis Services deployment wizard, we would use it for command line execution and integration with automated builds, script generation to hand to a DBA for deployment, processing on deployment as long as we're running the wizard in UI mode, and probably the biggest selling point of the deployment wizard was the retain partitions functionality. The target tabular models partitions are almost always created and managed by ETL processes, which means they don't exist in the version of the tabular model we get from source control. So we need a deployment method that will not mess with the partitions, and it will also not mess with other objects like roles that may be different across environments and connections that may be pointing at different instances of the source databases. BISM Normalizer covers all these use cases, and it does so in a different way to the deployment wizard. BISM Normalizer is basically schema compare for analysis services, and it's the only usable database compare product for analysis services. It's Visual Studio integrated, which is useful for deployment to the development server as part of the development process, which actually happens quite frequently when developing large enterprise scale tabular models that won't fit into the workspace database on the developer workstation. And when we deploy to dev, not only do we want to do so from Visual Studio, but we want to retain partitions on the development environment. We want it to match test and production as much as possible, and we want to make sure that our partitioning code is working before we deploy it. BISM Normalizer also introduces opportunity for different deployment strategies. Traditional deployment is all or nothing, which means we cannot deploy a bug fix from the development environment if there are also features that are unfinished and not ready for deployment. The standard way to address this is to create a production branch and do the bug fixes in there. You then need BISM Normalizer to merge the bug fixes from the production branch to the main branch, or you end up doing the same bug fix in two different places by hand. And I'd go so far as to say that if you use BISM Normalizer to merge from the production branch, you should also be using it for deployment, because that will standardize the tool set that you use for management of tabular models and improve the supportability of the solution. But the reality is that most implementations have not gone to the trouble of setting up a production branch. They may not have the organizational capability, they may not want to deal with the extra complexity, or they may just want the flexibility to deploy individual features through the environments based off customer requests. There are risks associated with that, but they're risks that many organizations are willing to take. BISM Normalizer also performs merging of tabular models. A typical tabular implementation might have 3, 4, or 5 tabular databases. It's not like multidimensional where we can have conformed dimensions and multiple cubes all in the same database. With tabular, we often replicate conformed dimensions, the date dimension, and sometimes even fact tables and measures across different tabular databases, and we want to do so without reinventing the wheel. In an enterprise organization, it may even make sense to standardize tabular objects across different groups of developers. And we can use it to merge Power Pivot migrated prototypes and self-service BI models into existing corporate BI tabular models. I'm now going to do a demo. We have this tabular model that we want to deploy a new version to a database on a server. We can select Tools, New Tabular Model Comparison, or Add New Tabular Model Comparison to a project. The source and target can be a project or a database. We can flip them back and forth. And the default values for the target, server and database are taken from the source project's deployment properties based on the current Visual Studio configuration. It supports all the tabular objects that the tabular model designer in Visual Studio supports. Displays their JSON object definitions and highlights any differences. At this point, we want to specify the actions to take on the target. Quite often we will skip connection updates to retain connection strings across environments. We'll do the same for the role update. We can skip items individually or in bulk. And a common use case when merging tabular models is that we want to reuse objects from the source but keep everything else that's in the target. In other words, we want to skip anything with a delete action item. We can do that by selecting Skip All Objects Missing in Source, and all the deletes get skipped. If we look at Fact Internet Sales, the source and target definitions are the same, except the target has multiple partitions whereas the source only has one. So we'd like to retain partitions in this case. The perspective has selections in the target for dim currency and dim customer, which happen to be two of the tables that we chose not to delete, that we skipped earlier. So as you can see, especially when merging tabular models, it's quite common to want to keep the selections in target perspectives, or in other words, to merge the selections from the source and target perspectives. We can do this by selecting For Perspective Updates, Merge Selections Not Replace. And the same concept applies to cultures, where we may want to keep translations in target cultures. We may choose to exclude roles from the comparison entirely, and we will uncheck Consider Query Partitions so that Fact Internet Sales doesn't even show up as a difference. We'll leave the processing options as they are. And as you can see, Fact Internet Sales now has the same definition and the partitions aren't displayed. And the target perspective has the selections grayed out to indicate that they won't be removed. If we look at the code behind the BSMN file, you can see that everything we just did has been saved to the file. So we can use these BSMN files kind of like configurations for deployment of specific databases and environments. If we reload the comparison, we're now in the same state that we were a moment ago, again because it loaded the information from the file. Validate selection, and it tells us what it's going to do. And it will display warnings for things like name conflicts and ambiguous relationship paths. BISM Normalizer is quite forgiving when compared to the leading relational database compare products, because they allow you to generate a script that when you come to execute on the target environment could fail for any number of reasons. Whereas BISM Normalizer will identify problems up front, display warnings, and disallow actions that would result in an error on deployment. We can now report differences, generate a script to hand to a DBA, or go ahead and update the target. It's now performing processing based on the processing options we specified in the options dialog. Refresh the comparison And as you can see, the changes have been applied except for those we chose to skip. I'm now going to run a different comparison that resets the target database back to the state it was in at the beginning of the demo. But this time I'm going to do it from the command line instead of from Visual Studio. So as you can see, the source of the comparison is a project. The command line interface supports projects as the source or target of comparisons. And the comparison obviously doesn't have to be loaded in the background in Visual Studio, it is just for demo purposes here. The reason it's important that the command line interface supports projects as source or target of comparisons is that that's useful for automated build operations that get the latest version of files from source control. We need to specify the BSMN file as a parameter, which again is the same one we have loaded in the background. We can specify a log file, and if we don't, the output will be displayed in the command window. A script file, in which case the target won't be updated, as scripts will be generated instead. And we can specify skip options like missing in source, which is equivalent to selecting skip all objects missing in source in the UI. The reason we might want to specify skip options from the command line is that we could use it for things like automated merge operations, where again we don't want to lose many of the objects in the target tabular model. The messages displayed are the same ones we normally see in the BISM Normalizer warning list. Refresh the comparison and it matches. So as you can see, BISM Normalizer is a very easy to use tool. It has a very simple user interface. It covers a great deal of use cases for management of tabular models, and there's nothing else out there that does what BISM Normalizer can do. Thank you for watching.